Okay, in this example here, we're told a data set is normally distributed with a mean of 23.8 and a standard deviation of 1.2. So in part A, what we're asked to find the z-scores for each raw score and describe it, or describe where it is on a standard normal distribution. So for each of these here, we do have to use the z-score formula, which is z is equal to x minus the mean over the standard deviation. So in the case of the first one here, its z-score is going to be equal to 25.7 minus 23.8. That's going to be over 1.2. So this z-score is equal to 1.58. And that's just rounding it off to two decimal places here. So what we would say is this lies 1.58 standard deviations to the right of the mean. In the second one here, like work out the z-score, so we're going to have 20.6 minus 23.8. And this is going to be over 1.2. Typing this into our calculator, we'll get our answer here. This is going to be a negative of 2.67. So what this is saying is it's lying below the mean, and it's 2.67 standard deviations below the mean here. And now we get to the third one here, and we've got 28.3. So that's minus the mean of 23.8. That's all over 1.2. So when we work this one out and we type into our calculator, we get an answer of 3.75. Now for this last one, this is lying to the right of the mean. However, being 3.75, it's extremely unlikely that this is going to be a result, because given 99.7% of results lie between -3 standard deviations below the mean and 3 positive standard deviations above the mean, given this one is greater than that, the chance of it occurring is extremely unlikely and generally just not going to occur. So now that leaves us with part B, which asks which of the following scores from part B are very unlikely. Well, I've kind of just answered that. That's going to be that score of 3.75. So 3.75, or the raw score of 28.3. So 28.3 is very unlikely to occur. And it's because of that reason, which I stated before, where now for part C, what we're asked to find is the value of a raw score whose z-score is negative 1.82 corrected to decimal places. So what this is doing is getting us to go from a z-score and convert it back to a normal score here. So what we're going to do is we're going to have negative 1.82 equal to x, because that's what we're trying to find here. And that's going to be minus 23.8 and all over 1.2. So what we're going to do is we're going to rearrange this. So we're going to move 1.2 to the other side, and then also add 23.8. What we end up with is this in our rearrangement of x is equal to 23.8 minus 1.2, and that's timesing against 1.82, the standard deviation. And so the raw score we work out here is going to be to 21.62, and that's rounded to two decimal places.